So welcome everyone. Uh, Today we'll do some examples on eigenvalues and eigenvectors. Eigenvalues और eigenvectors जो आपने किए हैं उसमें evaluation of eigenvectors आपने कैसे किए हैं? कौन कौन से methods पढ़े आपने?
उसमें सर 3 पढ़े।
Laplace वाला method पढ़ा आपने और
सिमिलैरिटी वाला
और
कैली हैमिल्टन
वाला। आप एक numerical लिखो। So this is a matrix, 3 cross 3 matrix.
Yes, sir.
You have to evaluate the eigenvalues and the eigenvectors. Simple, okay? So we'll first see the general case of evaluating the eigenvalues and the eigenvectors. So if you first of all write the characteristic equation of this matrix, it will look like what? You have to solve for lambda I minus a. So this will be the lambda I minus a matrix. Okay. So when you solve the eigenvalue system, the equations that you encounter is of the form this. You have to solve essentially this kind of equation, isn't it? AVI is equal to lambda IVI. This is a general representation. So A can be any matrix of dimension, let's suppose n cross n, which is having lambda values, which are the eigenvalues of the system, lambda 1, lambda 2, up to lambda n. And the only unknown in this equation is the Vi.
Yes, sir.
Which are the eigenvectors. Let's suppose we have V1i, V2i, up to Vni. So you have to solve this matrix vector equation, and the solution will give you the eigenvectors.
Yes.
Okay. So if we rearrange this, you may have seen the equation like this. Lambda I minus a into Vi equal to 0.
Yes, sir.
So this is a set of n homogeneous equations that you have to solve. And there are certain questions that you can ask before solving the equation. First of all, whether the solution exists or not. And if it exists, then you have to see whether it's a unique solution. So if you just solve this equation for this example.
Yes, sir.
So yeah, first of all, you have to evaluate the eigenvalues. Since it's a simple matrix, so you can solve for the eigenvalues. Evaluate the eigenvalues. And one more thing, when you solve this equation, you know this equation is equal to 0 when only the determinant of this will be 0, lambda I minus a. Then only you can solve this equation. This is a property. This equation is 0 only when this determinant of this lambda I minus a will be 0. Okay.
Yes, sir. Lambda is called minus 2, minus 2, minus 2.
Lambda plus 4, lambda plus 3, lambda plus 2 equal to 0.
Yes, sir.
When you solve the determinant of this lambda I minus, this is matrix, you have to solve the determinant of this and put it equal to 0. Then you will get this kind of equation, and this is very easy. Then you can say that lambdas are minus 2, minus 3, and minus 4. So you have to do the eigenvalues. Now we'll go for eigenvectors.
Yes.
And to solve the eigenvectors, you have to use this equation. This one. So what you will do, you will just substitute the, well, first of all write the eigenvalues again. Lambda is equal to -2, -3 and -4. And you have the equation lambda I minus a vi equal to 0. This is your equation.
Yes, sir.
So you can first substitute the first eigenvalue.
Yes, sir.
For I is equal to 1, the first eigenvalue will substitute, then we'll substitute the second, we'll substitute the, first of all we go to the first. Substitute I equal to, for I is equal to 1, lambda is equal to -2. I'll type the equation again. You had lambda plus 4 minus 1 0 0 lambda plus 3 minus 1 0 0 lambda plus 2. This was your lambda minus equation. Now for lambda equal to 2 or minus 2?
-2.
For lambda equal to -2, your equation this is the equation, isn't it?
Yes, sir.
Now the equation is, you have v1, v here, v1, v2, v3, and this is equal to 0. So basically you have to find a vector of length 3 which transforms this transformation takes this vector to the null space. So you have to evaluate this equation. So if you see, what's the rank of this matrix? What's the rank of this lambda I minus a equation?
2.
You can very easily see the last row is 0.
0.
जब भी 0 होगा तो आप सीधे कह सकते हो रैंक क्या होती है बेसिकली ऑर्डर ऑफ द हाईएस्ट नॉन वैनिशिंग डिटरमिनेंट. तो नॉन वैनिशिंग डिटरमिनेंट कौन सा है? ये देख लो 2 minus 0, so this is non-vanishing, so rank is 2.
Yes.
So from this you can solve the equation easily. So let's suppose we have 2 minus 1. Let's suppose we take this minor.
G.
0 1. Then you can have v1 v2 equal to 0. Then you can add system of equations for this. 2v1 minus v2 is equal to 0.
V2 is correct.
This will give no information. If you take this second equation, this will give you what? v2 minus v3. v2 minus v3 equal to 0. You have to take those kind of equations in which you apply all the variables, isn't it? Now this is underdetermined system because you are having 3 equations but only 3 unknowns but only 2 equations, isn't it? So underdetermined equation, it will have infinitely many solutions, isn't it?
Yes, sir.
आप एक काम कर सकते हो इसमें, you can substitute one and get the other 2.
Yes, sir.
है ना? तो आप इसमें v3 assume कर लो कुछ, the third component होता है. आप v3 assume कर लो. Let's suppose v3 is 1 or v3 is 2. So v2 is also 2, isn't it? And v1 is how much? 1.
Yes, sir.
तो एक solution मिल गया. मैंने assume कर लिया v3 is 2 in this equation. क्योंकि इसमें unknowns 3 है, equations खाली 2 हैं, तो मैंने assume किया v3 is 2. एक बार fix हो गया, now it's 2 equations, 2 unknowns. तो immediately you will get the solution as, तो आपका target vector आ गया. This is what? 1 1 2 1 2 2. This is the first eigenvector corresponding to eigenvalue lambda is equal to -2. है ना?
Yes, sir.
Similarly, if अगर आपको एक कोई वैल्यू चलते हैं यहाँ पे,
तो हम कुछ भी वैल्यू ले सकते
आप कुछ भी ले सकते हैं ना. तो in general you can have the solution like this. आप कोई भी अल्फा ले सकते हो, which will be a scaling factor here. और यहाँ पे you will get the solution of 1 to 2. So this will be the linearly depending on the alpha. आप क्या अल्फा लेते हो, you can get the 1 to 2 as the outside. So this is for one eigenvalue -2. Similarly you can go for -3 and -4. तो यहाँ पे जो important चीज है, वो ये है कि जो ये आपकी इक्वेशन है, you will get equation, you have to solve this equation only up to the rank of the system. The rank of system is 2, so you only have to solve 2 equations. So in general, you can write that for any system, you can write on the side the statement here. ये समझ में आया अल्फा कैसे? हाँ. You can write the general equation that the number of, so I have written here that the number of linearly independent solutions of homogeneous equation this that you are solving, that's equal to n. N is the order of the system minus the rank of this. n यहाँ पे 3 था और rank यहाँ पे 2 थी, है ना? That's equal to the gamma, and gamma is the nullity. We represent gamma as the nullity of matrix. This lambda I say. So this is one way. What you do is you just find the determinant of lambda I say, put them to 0 to get the eigenvalues, then solve this equation. तो यहाँ पे आपकी system of equations बनेंगी. If your rank is equal to the order of the system, you will get a perfectly 3 orders system जिसमें 3 equation 3 unknowns होंगे. And if the rank is less, then you get this underdetermined system, and you have to then substitute 1 to get the answer of the 2. Similarly, आप कर सकते हो for -3 and -4. Similar set of exercise करनी पड़ेगी. You have to substitute -3. वहाँ पे भी आपको ऐसा ही मिलेगा, and you have to solve it. ठीक है? This is one way to solve the. ये करें -3 -4 के लिए try. This is easy. हाँ करो. For lambda equal to -3, you are getting equation. क्या इक्वेशन आ रही है? v1 minus v2 is equal to 0, and another equation you are getting is v3 equal to 0.
Yes, sir.
This implies v1 is equal to v2. So your vector will be this subscript जो मैं लिख रहा हूँ ये components of v है.
Yes, sir.
ठीक है? So I am getting 1 1 0. Similarly, you can do for lambda is equal to -4. So for each corresponding eigenvalue, आपका एक eigenvector मिल जाएगा. Significance of these eigenvalues and eigenvectors is that eigenvalue gives you the scaling factor.
Yes.
And these eigenvectors are nothing but they are special vectors. When you have a transformation matrix A that transforms this vector into another vector, but the thing is the direction is reserved. Only the scaling has been changed. Either it's pushed or it's expanded, depending upon the sign of the eigenvalue. If it's positive, then your eigenvector is expanded, and it's negative, it's squished. The direction of this vector remains the same, because if you see on the left, you have a matrix vector product. On the right, you have a scalar vector product. So that's the significance of eigenvalues and eigenvectors. And also, your eigenvalues are used for stability analysis. What will you see further in the course? So, for example, करते हैं. This was by solving the state equations. हाँ, ये भी बता दो 4 के लिए क्या आएगा?
उसमें 0 1
मैं यहाँ पे आंसर लिख रहा हूँ v3. This is for lambda equal to 4 minus 4. You will get ऐसा आ रहा है 2 0 0. v3 is 0, v2 is 0, and v1 is 2. Let's take another example. X dot. Let's suppose we are given this dynamical system, linear dynamical system. And there's a single input, single output. So I'm representing this by scalars. So let's suppose that A is given like this. Zero 1 minus 24 0 0. This is your system matrix. Your B is given 2 5 0, and your C transpose Q minus 1 2 minus 1. This is the information given about the system, the A, B, and C. So first of all, evaluate the eigenvalues. I have to solve this equation basically. Then diamond C equals 0. I A is given as this. Just put this equal to 0 and solve for lambda. तो इस इक्वेशन को अगर आपको सिंपली लिखना हो, कैन रिमेंबर इट लाइक दिस. इफ यू इवैल्यूएट डिटरमिनेंट ऑफ लैम्डा आई मीन से जो डायगोनल एंट्रीज हैं उसमें लैम्डा ऐड होगा जी, और नॉन डायगोनल जो है उसमें बस साइन चेंज हो जाएगी जी. नहीं, लैम्डा ऐड हो रहा है कि लैम्डा सबट्रैक्ट हो रहा है. दिस इज लैम्डा minus 9. Minus of minus 9 will give you lambda plus 9. Lambda minus 0, lambda minus 0. Non-diagonal में आप simply sign change कर दें. So you have to solve this cubic equation. जी सर. तो मैं यहाँ पे लिख रहा हूँ roots. Lambda 1 is coming minus 2. Lambda 2 is coming minus 3 and lambda 3 is coming minus 4. तो same as previous exam. So भी यही roots आए थे. तो आपने पढ़ा होगा from linear algebra this property of so if you have M matrix M into adjoint of M is equal to determinant of M into I, where M is any matrix. तो अगर इस M में हम ये matrix डाल दें lambda minus A, then minus A is first of all a matrix, then we take its determinant. तो lambda minus A यहाँ पे डालें तो क्या होगा lambda minus A into adjoint of lambda minus A equal to determinant of lambda I minus A into I.
Yes, sir.
हमने simply M की जगह यहाँ पे ये matrix डाल दिया lambda minus A, and you know this thing determinant of lambda minus A by the property of eigenvalue eigenvectors. If lambda is the eigenvalue, then what is the determinant of lambda minus A? This will go to 0. है ना, जब करते हैं. So right hand side will go to 0. So you will get only lambda I minus A into adjoint of lambda I
is equal to 0.
is equal to 0. Okay, तो ये ठीक है यहाँ तक.
Yes, sir.
Now compare this equation with this equation. जो मैंने square boxes बनाए इन दो को comparison करो.
Vi is
First of all, you have lambda minus A into Vi equals 0 from the property of this. और दूसरा आपने evaluate किया this equation from this property of matrices linear algebra. Lambda minus A into adjoint of lambda minus A is equal to 0. So this Vi here, this is proportional to the non-zero columns of this because यहाँ पे एक matrix है, यहाँ पे आपके पास एक vector है. This is proportional to the non-zero columns of this matrix. So we will use this property. इसको use करके हम करेंगे solve for this eigenvectors. This is your lambda I minus A. And this is your adjoint of this. तो दोनों equations आपको adjoint आता है ना?
जी.
You have to take this and do the product.
Yes, sir.
That will become lambda square.
जी.
So when you take this, solve this. So this is lambda. हम adjoint से basically हम क्या कर रहे हैं, हम eigenvectors देख रहे हैं.
जी सर.
पिछले केस में हमने दिखाया था for just solve the equation.
जी.
यहाँ पे हम ये evaluate करेंगे property. तो if you substitute lambda equal to first lambda, अब मैं lambda लिख रहा हूँ फिर से -2 -3 -4. तो substitute -2 in this. यहाँ पे लिखा हुआ है substitute -2. So you will get the adjoint of lambda I minus a for corresponding to first eigenvalue. And that will be used to evaluate the first eigenvector. Here's answer from. लैम्डा में आंसर तो कर ही रहे हो। तो आपको लेना ही है फॉर आइगन वैल्यूज के लिए। अब यहाँ पे एडिशनल स्टेप क्या है, जस्ट टेक द एडजॉइंट ऑफ दिस। एडजॉइंट निकालना है, देन यू हैव टू सबस्टिट्यूट द फर्स्ट आइगन वैल्यू। तो यू विल गेट अ मैट्रिक्स दिस। यहाँ पे सीधा आंसर दिया ये आ रहा है जी। तो दिस इज फॉर लैम्डा इज इक्वल टू -2 जी सर, ठीक है। तो यहाँ पर अगर इस मैट्रिक्स को आप देखोगे, जैसे मैंने लिखा था ये हमने जो वैल्यू किया, दिस विल कॉरस्पॉन्डिंग टू vi, जो हमारा vi टर्म थी ना, vi इज प्रोपोर्शनल टू दिस मैट्रिक्स। तो अगर आप कॉलम्स को देखोगे, they are linearly dependent. Yes, sir. Isn't it? This is 1, 7, 20, 1, 7, 12. If you multiply with 2, you will get the second column. Yes, sir. Multiply with 4, you will get the first column. So, तीनों columns जो हैं linearly dependent है. Yes, sir. So, you can take any column. कोई भी column ले लो, that will be the first eigenvector. Yes, sir. So, your first eigenvector is simply 1, 7, and 12. Because it's linearly dependent है. This is 2 times scaling.
-24 लैम्डा into 2 हो गया -48, आपने लिखा 28।
1 second, 48 ही होना चाहिए, हाँ 48, because this is 4 times of this. So you can say the first 2 columns are combination of the third column. जी. So this is the important 1, 7, 12. This is the first eigenvector. Yes, sir. This is -2 scaling. This is 4 times scaling. Yes, sir. इसलिए मैं लिख रहा हूँ for second lambda, for lambda equal to -3. If you substitute -3, you will get a similar kind of matrix. तो इसमें eigenvector क्या लेंगे? आपको ऐसा matrix मिला. You have to see कि ये linearly dependent है आपस में ना. So you have to take any non-zero column. कोई भी non-zero column लोगे आप, that would be 168. This is another way of evaluating the eigenvector. इसमें आपको कोई equation solve नहीं करनी पड़ती है. हम जो करते हैं ना,
अगर सारे डिपेंड नहीं है एक दूसरे पे,
नहीं दिस विल कम डिपेंडेंट, क्योंकि हमने जो ये निकाला ना, adjoint of lambda I minus a, this is proportional to the v. We have lambda I minus a of equation 3. We have compared these two equations. So here is a vector, here is a matrix. है ना, हम compare कर रहे हैं vector with the matrix. So you will get any non-zero. You have to take any non-zero, क्योंकि we have evaluated from a property. जो properties evaluate करोगे उससे this will come in linearly dependent set. और आपको कोई भी column ले लो, ठीक है। अगर आपको एग्जाम में असाइनमेंट्स में दिखाना पड़े, you can take any column, क्योंकि आपस में डिपेंडेंट है जी। जैसे मैंने दिखाया अल्फा, तो here alpha is -2 and alpha is 4. इस तरह alpha is 3 -3. Yes sir. And is +3 जी। 3 9. तो इसमें आपको कोई इक्वेशन सॉल्व नहीं करना। तो these are two methods of solving eigenvectors. या तो आप ये वाली इक्वेशन ले लो, lambda I minus a into vi equal to 0, and check कि कौन सा vi आपको ले रहा है to 0 जी। इसमें आपको वो डिटरमाइंड और exact solutions मिल सकते हैं, 3 kind of solutions. Second method is to solve this equation, lambda I minus a adjoint of this equal to 0. From here you have to evaluate this matrix adjoint of lambda I minus a. Lambda I minus आपके पास पहले से होगा, you just have to take the adjoint. This is only one additional step. आपको बस adjoint लेना है, and from that you will substitute 1 by 1 each eigenvalue, and correspondingly you will get matrices, and you can take any column of the matrix. यहाँ पे हम ये ले लिया और यहाँ पे हम ये दोनों तरीके आपके पास, कैन वेरीफाई दिस। और स्टार्ट हम कर रहे हैं लैम्डा I से, ये इक्वेशन तो आपके पास पहले से होती है, तो इसमें खाली एडिशनल स्टेप है एडजॉइंट लेना है, ठीक है। अच्छा, ये हो गया आइगन वैल्यूज और आइगन वेक्टर्स की वैल्यूएशन। इसके अलावा आपने क्या पढ़ा है? सॉल्यूशंस, Solution of state equations पढ़ा होगा आपने.
जी,
So we take one example of solution now. So this is a system. ये आपका है A matrix and you are given only an initial condition. This initial condition for the first state variable and the second variable 1 0. What you have to do is evaluate the solution. This is a homogeneous system. इसमें कोई force and function नहीं है.
जी.
तो इसके लिए आपको निकालना है the solution. पहले इतना करते हैं. Then you will add a force and function to it. पहले इसका आप solution देखो क्या होता है. What's the general solution of this? xt क्या होता है बराबर? e to the power 80 into x0. यही होता है ना? अगर खाली इतना पूछा गया है कि आपके पास एक मैट्रिक्स है एंड इनिशियल कंडीशन है. So all the computation has to be done on this e to the power 80. So this e to the power 80 is equal to the Laplace inverse of पढ़ा होगा आपने si minus a inverse. ये होता है. So again you see similar kind of equation comes up. Si minus a. तो si minus a तो इसकी काफी प्रैक्टिस होनी चाहिए आपको. Evaluate fast this si minus a and the inverse. Then आपको क्या करना है उसका Laplace inverse लेना है. And once you get the matrix, you have to then multiply with the initial condition. तो टू ऑर्डर सिस्टम में इनवर्स निकालना काफी इजी होता है टू ऑर्डर सिस्टम में. तो उसमें आप निकालो पहले जरा असाइनमेंट्स ये को स्टेप बाय स्टेप. पहले असाइनमेंट्स ए निकालो, देन डू द इनवर्स, देन डू द लाप्लास इनवर्स. तो असाइनमेंट्स से क्या होगा? s s plus 2 minus 1 and 0. This is assignments a. Now do the inverse.
S plus 2
The diagonal elements change their position and non-diagonal change their sign. This is the adjoint. तो इसमें डिवाइड भी क्या आएगा? 1 by s into s plus 2. आएगा ना डिनोमिनेटर में एक्स्ट्रा टर्म. ये तो 0 है.
Yes.
So this is the adjoint divided by the determinant. This is the inverse.
Yes, sir.
तो उसको आप ऐसे भी लिख सकते हो 1 by s into s plus 2. ये तो 0 ही है. And this is 1 by s plus 2. ऐसे लिख सकते हैं.
जी.
This is your assignments A inverse. This is Laplace S. तो इसका Laplace inverse दिखाओ. And that will be your e to the power 80. If you do the Laplace inverse
E power t
of this, that will give you e to the power 80. And इसका 1 basically ut लिखते हैं और 1. इसका क्या आएगा? 1 by s into s plus 2. इसका usually partial fractions करते हैं. इसका करते हैं जो आपका था 1 by. We do it like this. To be 1 over 2 1 by s minus 1 minus s नहीं आएगा. 1 minus e to the power minus 2t. ये आएगा ना partial fraction a 1 by 2 b 1 by 2 b minus 1 by 2. तो 1 by 2 1 minus e to the power minus 2t. इसका तो 0 ही है और इसका आएगा e to the power minus 2t. This is your e to the power 80 matrix. It will be a function of time only. इसमें कोई लाप्लास नहीं होगा क्योंकि हमने इनवर्स किया है. So this is your e to the power 80. अब क्या करना है? The solution is what? Into x0.
Into x0.
तो करो multiply to the power x0. If you see last time सिखाया था 1 0 only you are having 1, which means the first column is of importance.
Yes, sir.
तो जो भी यहाँ पे evaluate होगा that will be multiplied with 0.
Yes, sir.
So if you know linear algebra by heart, you can say that only the first column is important. Whatever is here is multiplied with 0 because of the initial condition. So your e to the power 80 into x0, which is 1 0, half of 1 minus e to the power minus 2t, then e to the power minus 2t times 1 0. and this is 1 0. हम evaluate कर रहे हैं x of t. So उसको आप ऐसे भी अगर आप प्रोडक्ट भी करोगे वो भी सही है. अगर आप ऐसे भी विजुलाइज करोगे if it's 1 0, so this means 1 times the first column and 0 times the second column.
Yes, sir.
तो ये पार्ट इवैल्यूएट करने की जरूरत नहीं है. इन द सॉल्यूशन से कोई कंट्रीब्यूशन नहीं होगा.
जी सर.
Because of this 0.
Yes, sir.
अगर 1 1 होता then you have to add. So simply it's 1 0. Consider now that the system has a forcing function. And is represented by the following. Green color फिर आता है वीडियो में सही.
Yes, sir.
Consider now the system has a forcing function and is represented by the following non-homogeneous state equations. अब इसमें u वाले टर्म आ गए, so this becomes a non-homogeneous. अभी तक b टर्म नहीं है, u was 0 अभी तक. u 0 था, you are evaluating the solution just from the initial condition.
Yes, sir.
अब आपके पास क्या है? इस पार्ट में you have a forcing function u, where u is a unit step.
Yes, sir.
Now compute the solution of this equation assuming the initial conditions of part A. जो part पहले में initial conditions था क्या था 1 0. You have to assume these initial conditions, and on top of that you have to assume this forcing function. So this becomes the complete solution now. इसका आपको solution निकालना है. So what's the general solution of solving such kind of systems? What's the equation looks like? X of t e to the power at
X naught of
x naught. This is for the homogeneous part, plus some initial time t naught to t अगर आपके पास फोर्स फंक्शन नहीं है तो खाली इतना आपका सोल्यूशन है जो हमने इवैल्यूएट किया था टू द पावर 80 x डॉट विल बी अ वेक्टर. नाउ फॉर नॉन होमोजेनियस विद सम फोर्स फंक्शन यू विल बी हैविंग एडिशनल पार्ट ऑफ दिस. तो यहाँ पे जो इंटीग्रेशन हुई है फ्रॉम t नॉट टू t, ठीक है
जी.
अगर आपका जो इनिशियल कंडीशन है वो गिवन है टाइम t 0, देन दिस विल बी 0.
जी.
इनिशियल कंडीशन अगर t इज इक्वल टू 0 पे गिवन है, दिस इज 0. अगर 0 पे नहीं गिवन है फॉर सम जनरल t नॉट, तो हम t नॉट टू t लिखते हैं. ठीक है, तो ये तो पहले पार्ट में आपने इवैल्यूएट कर लिया. यू जस्ट हैव टू ऐड दिस पार्ट नाउ, है ना. तो ये इवैल्यूएट करना है. दिस इज द इंटीग्रल. तो इस इंटीग्रल को पहले लिखते हैं t नॉट टू t व्हाट इज e टू द पावर 80 जो इवैल्यूएट किया था हमने पिछले पार्ट में. b क्या गिवन है? b हमने यहाँ पे लिखा है.
जी सर. B गिवन है.
b गिवन है. b इज व्हाट 0 1.
B is
यहाँ पे लिख लेते हैं b इज 0 1. तो यहाँ पे भी एक आप एडवांटेज ले सकते हो फ्रॉम दिस b. Here b is 0 1. इससे ये आप एडवांटेज ले सकते हो कि ओनली द सेकंड कॉलम विल बी इंपॉर्टेंट. क्योंकि आप क्या कर रहे हैं यहाँ पे हर जगह जहाँ पे देखो मैट्रिक्स है
जी.
दिस इज अ वेक्टर.
जी.
तो मैट्रिक्स वेक्टर प्रोडक्ट करना है
जी.
और जिस वेक्टर जो है आपका दिस इज 0 1
0 है तो
and this is some matrix.
जी.
So only the second column is important
Yes sir.
because the first column is going to multiply with 0.
Yes sir.
So just take the second column of the e to the power 80
1/2
to t. Let's suppose the initial condition is given at time 0.
0 t
1 minus e to the power minus 2t आई थी ना पहली टर्म.
जी.
लेकिन यहाँ पे t minus tau होगा.
t minus tau.
बस ये डिफरेंस है. t will be replaced by t minus tau.
जी.
And the integration is with respect to tau. So this is the first entry of the second column.
जी.
और second entry is e to the power minus 2t. तो यहाँ पे लिखेंगे हम 2t minus tau.
t minus tau.
And integration is from 0 to t d tau.
d tau.
This is a vector. And what is this? This is e to the power a t minus tau into b.
जी
U tau d tau. With respect to 0 to t. ये लिखा मैंने यहाँ पे. तो यहाँ पे मैंने पहले ही ये लिया कि जो e to the power t minus tau उसको मैंने सेकंड कॉलम लिया. सेकंड कॉलम को मल्टीप्लाई किया मैंने
1
0 1 के साथ. So this is basically e to the power a t minus tau into b. And then you have u tau d tau. And u tau is a step input. ठीक है. तो it boils down to this equation. है ना? वेक्टर आएगा ना?
जी
Because यहाँ पे this is a vector and addition होगा this is whole a vector. है ना? To give it a 2 cross 1 answer. है ना? So vector will be added to a vector. So this is the vector. अब इसमें क्या है? यहाँ पे कोई Laplace variable नहीं है. Again you have time. And you have to integrate this equation.
जी
And then you will get an answer. तो उसका क्या इंटीग्रेशन आएगा? Limits are 0 to t. हाफ जो है बाहर ले लिया हमने.
जी
This is the second part. समझ आया कैसे आया?
यस सर.
अब जस्ट हैव टू डू इंटीग्रेशन. 1 का क्या आएगा? 1 का तो t ही आएगा जब डालेंगे. So you have to do the integration of this e to the power minus 2 t minus tau. और with respect to tau करना है. जब with respect to tau करोगे this t can come outside.
जी
तो आप e to the power minus 2t को बाहर ले लो and just do the integration of what? e to the
e
power 2 tau. बस 2 tau का उसका क्या आएगा? e to the power 2 tau by 2.
2 tau by 2 yes sir.
Then substitute the limits. और जो similar kind of expression is on this. आप करो. Just integration करनी है.
जी
With respect to tau. And then substitute the limits 0 to t. तो 1 का क्या आएगा? t
2t by 2
बाहर है 1 by 2. That is this term 1 by 2t.
जी
और जो इस पार्ट का है, इस पार्ट से जो आपके आएंगे दो वेरिएबल्स.
जी
एक तो आ रहा है ये 1 by 4 e to the power minus 2t और आ रहा है minus 1 by 4.
जी
तो इसके क्या करोगे? I will write it. पहला 1 by 2. This will be t. 1 by 2 को बाहर ले लो. This will be t minus e to the power minus 2t को बाहर ले सकते हो. You have to do the integration of e to the power 2 tau. That's equal to e to the power 2t by 2.
यस सर.
नहीं
3 आएगा.
नहीं आएगा.
जी
ये जीरो भी नहीं दिया हमने, खाली अपर लिमिट दिया. You have to take the zero as well. Upper limit minus lower limit. Upper limit c to the power minus 2t आएगा.
जी
और when you substitute 0, you will get half. आप ये वाला देखो e to the power minus
1 by 2 आएगा ना.
t e to the power 2
वहाँ पे
tau.
minus 1 by 2.
Basically ऐसा है आपका 0 to t, है ना? I have just taken this term.
जी
e to the power 2t को बाहर ले सकते हैं, अंदर रहेगा e to the power 2 tau.
जी
इसकी इंटीग्रेशन करनी है. e to the power 2t इसका आएगा e to the power 2 tau by 2 with the limit 0 to t.
t yes
Then you will take e to the power minus 2t. This will be to the power 2t by 2 minus 1 by 2.
1 by 2
वही कह रहा था, ये 1 by half इधर आएगा.
जी
This is the integration of just this part.
yes
और this is again similar to this. तो ये सेम ही आएगा. यहाँ पे बस आपका 1 by 2 t t by 2
जी
t by 2 ये बाहर आएगा. तो this half, so t by 2 यहाँ है, minus 1 by 4 इधर है, और इसका प्रोडक्ट क्या आएगा?
सर ये तो 1 आ रहा है. 1 by 2 आ रहा है.
1 by 2 आ रहा है. गलत तो नहीं हो? This is like this.
जी सर.
हाँ ऐसे ब्रैकेट्स बोलिए हम. This is brackets like this. तो 1 by 4 is this, minus 1 by 4. Then you have this thing. यहाँ से आएगा 1 by 4. This is 1
1
1 by 2 1 by 2 and 1 by 2 will give 1 by 4,
1 by 4
and this will give e to the power minus 2t
जी सर.
by 4.
जी
वो यहाँ पर है.
जी
ठीक है. And similar expression is here.
सर वो प्लस नहीं आएगा, माइनस आएगा.
कहाँ
माइनस
पे?
माइनस प्लस. जी सर प्लस ही आएगा.
ठीक है. This is the integration, just the integration of this. तो ये आपका आ गया the homogeneous part.
जी
So what will be the complete solution?
LT plus CP.
So then I can write the answer, the final answer. This will be 3 by 4
T is equal
plus 1 by 2t.
1 0
क्योंकि element wise है ना, element wise आएगा,
जी।
हम एक वेक्टर को सॉल्व करें.
1 0
And this is x2t. This is half of 1 minus c to the power minus 2t. This is the final answer. ये दो कंपोनेंट आ रहे हैं, x1 का अलग कंपोनेंट आ रहा है, x2 का अलग कंपोनेंट आ रहा है.
जी
Don't forget to add. This is the non-homogeneous part. इसमें आपको बस ऐड करना है तो homogeneous part, which is 1 0 था.
x1 x2 जी
ये homogeneous का solution क्या आ रहा था? 1 0 आ रहा था.
1 0 1 by 2
Then
1
add
minus e
this.
power 2t जी.
So you have to add this matrix. Sorry, vector. तो this is x1 x2. यहाँ से x1 t है आपका, x2 t है, क्योंकि दो कंपोनेंट है ना आपके, सेकंड ऑर्डर सिस्टम था. So this solution we got from part 1 and this solution we got from part 2 with a unit step input.
जी
So just add the two and then do element wise, you will get this kind of answer.
जी
This is how you solve
जी
a system with having both homogeneous part and non-homogeneous part.
non-homogeneous.
We'll stop here.